A twice differentiable function, a twice differentiable function f is such that if fa equal to fb equal to 0 and fc is greater than 0 for a c greater than a less than b. Prove that for at least there exists a zeta belonging to a comma b such that if double dash zeta is less than 0. This is the thing. That means again, whenever they talk about a double derivative, mostly in this type of situation, most of the cases, when for a single you need to divide this interval ab, upper interval ab as ac, closed interval ab into closed interval ac union and break up into cb. This is the point. There should be one zeta 1 here and one zeta 2 here. Between this zeta 1 and zeta 2 there is a zeta for which f double dash zeta is there. This is actually you have to apply Lagrange once here, apply Lagrange between these two. देखो जब भी एस टाइप का डबल डेरिवेटिव वाले का क्वेश्चन ऐसा पूछेगा ना, तो जो भी इंटरवल है क्लोज्ड इंटरवल, उसको दो क्लोज इंटरवल में तोड़ो, उनके बीच में लग्रांज लगाओ तो एक जाई आएगा, इन दोनों के बीच में एक लग्रांज लगाओ एक जाई 2 आएगा, अब इन दोनों के बीच में एक लग्रांज लगाओ तब एक जाई आएगा. दिस इज द आइडिया बेसिकली. ये दिस इज द आइडिया बिटवीन दिस ओपन इंटरवल ब्रेक इनटू टू इंटरवल्स, अप्लाई लग्रांज इन हियर, apply Lagrange here, get this and get this, and then apply Lagrange between this to get this. This is the idea. Now we will do this question. How the process of this question is this way. See, now see, f double dash exists. That means f and f dash both exist. F and f dash are both continuous, CTS continuous and different derivable on AC, I told you to break it, and CB this way. Now and apply LMVT, Lagrange mean value theorem, to both these intervals. Lagrange mean value theorem to both these intervals. Now for the first interval, you see, wait a minute, for the first interval, for f of c minus f of a upon c minus a, you will have f zeta 1, where zeta 1 is in between a and c. Now you will apply a Lagrange mean value theorem for this. Now it will be fb minus fc upon b minus c, and you will have f dash, this is f dash zeta 2, where zeta 2 is in between c and b. Now it's already given to you that fa here, you see this fa and fb are 0. fa and fb are 0 and fc is greater than 0. This condition is also very important. fc is greater than 0. Now let's come down to this. Now fa and fb is 0 and fc is greater than 0. This condition is given. Therefore, from the above, f dash zeta 1 is equal to fc upon c minus a, and you have f dash zeta 2, you have fb 0 minus fc upon b minus c. Now since this f dash is continuous and differentiable, again we will use as f dash is continuous and differentiable, so differentiable on xi1, zeta 2, zeta 1, and differentiable on zeta. So applying LMVT, we have f of zeta 2 minus f of zeta 1 upon zeta 2 minus zeta 1 and zeta 2 minus zeta 1 is equal to f double dash. This is dash dash, sorry. F double dash zeta, because we did for f, this will now be dash. This both will be now dash. We are applying on this. Now this zeta is in between zeta 1 and zeta 2. Now let us put the values of f zeta 1 and f zeta 2 here. Let us put the values. Now let us put the values. F zeta 2 is minus fc upon wait a minute, f minus fc upon b minus c minus what is f zeta 1? F zeta 1 is fc and c minus a. fc and c minus a. fc and c minus a upon zeta 2 minus zeta 1, and this is nothing but f double dash zeta. Now take fc common. Take minus fc common rather. So f double dash zeta, you take minus fc out. So you have upon zeta 2 minus zeta 1, and in the bracket you can write 1 upon b minus c plus 1 upon c minus a. Now take the LCM. If you take the LCM, f double dash xi is minus fc upon zeta 2 minus zeta 1. Now this will be c minus a plus b minus c. Just a minute, b minus c, and this will be b minus c and c minus a. Now you have c and c goes off. So what you are left with, f double dash zeta is minus f of c upon zeta 2 minus zeta 1, and this is b minus a upon b minus c and c minus a. Now understand how the situation is. So why this quantity is negative, I will tell you. See. Now see, you have a less than zeta 1 less than c less than zeta 2 less than b. So this condition is there. So b minus a is of course greater than 0. B minus c is of course greater than 0, taking these two. And c minus a, taking this and this. C minus a is also greater than 0. And xi 2 minus xi 1 is also greater than 0, taking this and this. So this whole quantity other than the minus, this quantity I'm talking about, this quantity is positive. This whole quantity is positive, but there is a minus sign. This whole quantity is positive, but there is a minus sign outside. Therefore, f double dash xi is less than 0. Now, another question we are going to do, that is, let us draw a line. Wait a minute. Yes. Now, the question is, if f dash and g dash are continuous on a minus h and a plus h, and derivable on open interval a minus h and a plus h, then show that then prove that f a plus h minus 2fa plus f a plus a minus h upon g a plus h minus 2ga plus g a minus h is equal to f double dash d and g double dash d. Now for some d, there exists a d belonging to open interval a minus h and a plus h, a minus h and a plus h, and ga plus h minus 2a plus g a plus h is never 0, and g double dash t is never 0 for t belonging to, for all t belonging to this open interval a minus h to a plus h. What it is trying to say, f double dash are continuous, that means f is continuous, and this, whenever I told you, whenever this double sort of derivative have been asked, that means you need to use this break up the interval. You need to break up the interval first condition, and then you need to do get the Rolle's theorem done. You need to क्या करना है, जब भी ऐसे डबल डेरिवेटिव देखोगे यहाँ पे, तो ज्यादातर समय क्या करना होता है, इस टोटल इंटरवल को ब्रेक करना होता है. ब्रेक करने का 2 पॉइंट मिलेंगे, उस पर फिर रोल्स थ्योरम लगाना पड़ेगा. दैट्स द बेसिक आइडिया. इसके लिए यू नीड टू थिंक अबाउट अ फंक्शन. Take this as fx, take this as gx, the whole function as gx, and take this as a. Best option. Take this as a, take this as fx, take this as gx. Now in this, you don't have to find the theta between d is between 0 and 1. That's not the case here. Do not confuse with the one video I did like this in earlier. In that I had to show something else. Don't confuse with that. This is not this. So now you take your function phi x as fx plus agx, no problem. Even if you take it this way, no problem. Now you break this interval. Now you know one thing. Break this interval a minus h to a, one interval, and the other interval is a to a plus h. Now what will happen is that phi a minus h should be equal to phi of a here, and phi of a here is equal to phi a plus h. That means this gives you phi a minus h, because I have to apply roles. मुझे roles लगाना है यहाँ पे. Double derivative है, because there is a double derivative, I have to apply roles 2 times. Now see, is equal to phi a is equal to phi a plus h. No problem. Now break this. There is a t1. Now since f dash is, see what are they saying? F dash and g dash. So f and g are continuous and they are differentiable. So f and g are continuous and differentiable. So phi of x. What is phi of x? I just wrote it down. What is phi? What was phi of x? It was fx plus agx. Now function. This function is continuous and differential. This is function continuous and differentiable. So phi x, you have to take this in 2 different intervals. You have to take this in 2 different intervals. See, what you do is that phi x is continuous on one you take from a minus h to a, the other you take a to a plus h, right? Phi x is derivable on open interval a minus h to a and the open interval a and a plus h. Now see, now phi of a plus h, a minus h, is equal to phi of a, and phi of a is equal to phi of a plus h. So Rolle's theorem is valid in both the intervals. So apply Rolle's in both the intervals. So there is a t1. So Rolle's theorem can be applied. Rolle's theorem, देखो रोल्स के तीनों कंडीशन हो गए, एक इस इंटरवल में, एक इस इंटरवल में, एक इस इंटरवल में, तो एक इधर वाले इंटरवल में रोल्स थ्योरम, एक इधर वाले इंटरवल में रोल्स थ्योरम आ गया. So there was so the Rolle's theorem is applicable in both the intervals because of all the 3 conditions been applying. So Rolle's theorem is applicable. So by Rolle's theorem, let me write. So by Rolle's theorem, why should I write so big? So by Rolle's theorem, you have phi dash t1 equal to 0 on which interval? On this interval, on this where this t1 belongs to open interval a minus h to a, and phi dash t2 is equal to 0 for this t2 belonging to a and a plus h. Further, when you take the derivative of this, see, phi dash of x is nothing but f dash x plus a g dash x. Further, this f dash x is, they are saying in the question, see in the question में देखो क्या बोल रहा है. These are continuous and differentiable again. So again, you see one thing. That means the first two conditions of roles are clear. So phi dash x is sorry, let me write it down like this. Wait a minute. Before I write this statement, before I write this statement, let me tell you one thing. This is a minus h, this is t1, this is a, this is t2, and a plus h. Now things will be clear for you. This is the way the things are going. Now, see one thing. Now we are going to find, see, phi x is continuous on your this uh, again this on this t1 and t2 is phi dash x is derivable because it is on the whole interval. See the question what they are saying. Question में देखो क्या बोल रहा है. In the question they are saying this function is continuous in this whole interval, is derivable on this whole interval, this interval. So it is possible that it is derivable and continuous on t1 t2. So it is possible derivable on, because t1 t2 is inside this t1 comma t2. Now phi of t1 phi of t1 phi dash t1 I just showed you here. See, phi dash t1 is what? 0. Phi dash t2 is what? 0. Very nice. Phi 1 t dash is phi 1 phi 2, sorry, phi dash t1, sorry, phi dash t1, phi dash, sorry, phi dash t2, phi dash t2 is, this is 0. So roles three conditions are satisfied. There exists a d between t1 and t2, which is a subset of a minus h to a plus h. This is possible. This is obvious because t1 and t2 you can see here. Now there exists that phi double dash d is equal to 0. Now, what is phi dash x? Phi dash x is f dash x plus a g dash x. Now, phi double dash x is f double dash x plus a g double dash x. That does the job. Now at phi double dash d is 0. So this implies f double dash d plus a g double dash d is equal to 0. That means minus a is f double dash d upon g double dash d. Now you see one thing, one very important conclusion. Now can you see this here? I have written this thing once and this thing once. I hope you are getting this point. This equation and this equation, this and this. I hope you are getting this too. Now you see, I will use this now. Now I can say, see one thing, I can say like this. I can say like this, phi a minus h is equal to phi of a. And I have said phi of a plus h is equal to phi of a. So adding phi of a plus h plus phi of a minus h is equal to 2 times phi of a. No problem. Adding them. Now what is phi of x? Phi of x was fx plus a gx. Just phi of a. What is this then? fa plus h plus a g a plus h. The first part for this now. Fa minus h plus a g a minus h. Now what is phi of a? Is 2 times fa plus 2 times a g of a. This is the thing. Now take a on one side. Take a on one side. Fa plus h. Then bring this here. Minus 2fa plus fa minus h is equal to, take the a there and take minus a common. Take a there and take minus common. So this becomes ga plus h minus 2ga and plus g a minus a minus, wait a minute, just a minute. This has become, wait. Just a minute. Just a minute. Let me, just a minute. Let me rub this a little bit. Rub this all and let me rewrite it in one line. Now, here it is. Fa plus h. Now, bring this here. This one here. Minus 2f of a. Write it here. Plus f of a minus h. Take this there on the other side and take minus a common. You will get ga plus h. Now this is a plus and the minus sign is out. So minus 2ga plus g of a minus h. A minus h and the whole bracket. So minus a is equal to fa plus h minus 2f of a plus f of a minus h upon g of a plus h minus 2g of a plus g of a minus h. Now can you see this? Minus a is this quantity here and minus a is this quantity here, this quantity, and you can see this quantity. You can see this quantity, both are minus a. So f double dash d upon g double dash d is equal to fa plus h minus 2f of a plus f of a minus h upon ga plus h minus 2g of a plus ga minus h.